Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In the last video, somebody noticed that the seconds on the clock went above 60, and you'll notice that all of them go above 60. So I thought in this video I'll show you where I went wrong on that and how to set the clock through the nextion. The error occurs over here in the RTC tab, where I send the data to the display. Up here in this area is where I collect the data, and when you bring the data in, it comes in under a format called BCD. And the problem is when I send it up, I don't convert it. I'll show you how I convert it here in a little bit, but the first thing I want to do is just alter the code. And you can see where I set the month. I'm just sending the string. I'm converting that month that I collected and sending it back up. What I need to do is I need to convert it from BCD to decimal and then send it up. And if I'm writing to the display, or if I'm writing to the real-time clock, I'll need to take decimal and convert it to BCD. I'm going to go through and convert all the rest of them now. I also, on this one, had day instead of date. And on the hour, when I was going less than 10, there's another thing we'll have to adjust on the hour because it reports back more than just the hour. It also reports back AM and PM, so a little modification has to be done here also. And in this case, we're going to take the modulus. So we'll take the modulus of 32 or the remainder, and then we'll compare that because we have to strip off some of the extra data. For the minute, we just have to do the conversion. The same for the second. And I want my clock to report AM, PM. I want it to be a 12-hour clock. So I'm going to add this. So when I divide that hour by 32, it will give me, since it's an integer, it won't give me a decimal point. It won't be floating. So just like getting the modulus of 32 returns the hour, dividing it by 32 will return the remainder of the information. And in this case, if it's a 3, then it's PM, and if it's a 2, it's AM. Now up here where I set the time, I'm going to delete all this and turn it into a function. And we're going to call that function setTime. And we're going to send it in the form of month, day, year, hour, minute, seconds, and then AM or PM. So I have these two functions here called BCD to decimal and decimal to BCD. I've gone over this in another video, and I believe I can put a link in the upper right hand corner to that video to go into a little more detail. But for this video, just trust that these do convert the data the correct way. Then I'm going to add this other function called setTime. And the string above that we're sending to it, I have set up in decimal. So the date would be 12, or the month could be 12, and then the day could be 23 or something like that. Just to make it easier, it's set up in decimal. So we're going to have to convert each one of these into BCD. And so the first letters are going to be month, then the date, then the year, then the hour, then the minute, then the second, then the AM and PM. We're going to use the substring function to break it up into sets of 2 characters per. As I created the variables to send, I converted them from decimal to BCD. And now I'm going to go through and write them to the real-time clock. And you can see that I'll begin the transmission, and then I'll wire write, and that's just the beginning address, which is 0. And you can see up at the top there that address 0 is the seconds. And this is where the BCD is important, because the ones for the seconds is the first 4 bits. So that just goes from 0 to 9. And in binary, 1001 is 9. And then the 10th of seconds, or the 10 space, is the 4, 5, and 6 bit. And that's why you need to take that and convert that decimal into BCD. So it almost could be also interpreted as hex. So you could write that same thing in hex and it would work also. And I do the same thing for minutes, because minutes is 0 through 9 is the first 4 bits, and then the 1 through 5 is the minutes, the 4, 5, and 6. And you can see that bit 7 isn't used for either one of those. But once we get to the hour, we need to manipulate things a little bit, because the first 4 bits are the hour, 0 through 9, and then depending on whether you have a 24-hour clock or not, bit 4 signifies 10 to 19, and then bit 5 would be 20, 21, 22, 23, and 24. And if it's a 12-hour clock, bit 4, 10, 11, and 12, and then bit 5 designates AM and PM. And then bit 6 is the one that tells you whether it's a 12 or 24 o'clock. And in our case, we want to use a 12, so bit 6 will always be set. And so if it's AM, you would take your hour, whatever it is, and you would add that bit 6. You would set it high, or add a 4 to that second 4 bits. And you can see I do that with hex. So if it's PM, I'm going to add 6, because you'd want bit 5 and 6 set. But if it's AM, I want to add a 4. But notice that 0 times, or the 0x, that designates it as hex. So we're just going to add it to whatever we have, and that should work out fine. And then the day, we don't really care. We're not using that anyway. I just leave that at 4. It seems to work. I've never actually played with the day, so I'm not 100% sure if I could have just set that to 0. The date is the same. It doesn't use the bit 6 or bit 7, but you do have to convert it to BCD, because 3 would be the highest number you'd have to get, so you'd only have 4 and 5 to be set. Now the month also includes the century. In the other areas, I do the modulus of 120, so that just knocks that century bit off. And when I set it, I'm not setting the century, so I can just set it to the month that I want. And then the year is just the modulus, but it uses the whole thing, because it could be 9 and 9. And then we end the transmission. And that's how come you need to convert the decimal to BCD. And when you read it from the real-time clock, you take that BCD and convert it back to decimal. And now at the beginning, you saw that it wasn't working. So now I'm going to upload this to the Arduino, switch to the camera, and hopefully it works now. And you can see I've got everything right except for that it's adding a 0 to the 16. I'm going to go back real quick and look at the code and see why it added that. And you can see right here, it's if the day is greater than 10, and it should be the date. So we'll just make that change and we'll upload it again, and it should work now. And now we've got it all set in there. The only problem is it's not incrementing because we're continuing to set that. So I'll go back and I'll comment out that line where we set the clock, and then I'll come back. And now you can see that it's counting up. The only problem is we can't really see if it's going to roll over. So we'll make one more change where we'll set the time to right before it's going to be like at 11:59 p.m. And we know how to do that in here. We'll go 5, 16, 22, and then we'll change this to 11:59, and we'll set it to 30 seconds. So I'm going to do this again, then I'm going to have to upload it, then I'll comment it out, and I'll upload it again, and we'll pick up from that point. And now, if all goes well, it should go to 12 a.m., and this should go to 5, 6, 17. And there we go. So now we should be working just fine. And we also have a setup now where we can send a string set up in that format where we have 2 digits for the month, day, year, hour, minute, second, and AM, PM. And we should be able to set this clock. So now it's just a matter of going to this nextion and changing that a little bit so we can send a string. I'm going to go over that next. Now up here I've added the AM, and then I wanted to make sure I had enough space, and it just barely fits in there. So everything should be good. And then I've added a time button down here. And that's all I did on the main page. I didn't do anything to this temperature page. That's all the same. But what I did add is on this page 2 where I can set the time. And on here I have this button, and all it does is sends it back to page 0. And then this up button, what it's going to do is it's going to have the words up or down. If you click on it and it says up, it's going to change it to down. and if it has anything else on it, it's going to change it to up. And I'm going to use that button to increment or decrement the months, day, year, hour, minutes, and second. So if I click on this N0, which is my months, which should just be a value of 1 through 12, if B2 has the up text on it, it's going to increment N0. If N0 is greater than 12, it'll make it 12, so we won't be able to go above 12. Or, in the case of it being down, we're going to decrement it. We're going to do that for each one of these. So if it says up, the day won't go above 31. And I know that's not going to work for all months like February, but for what we're doing, it should be fine. You just have to know not to go above that. And if we did put that in, I don't know what would happen. We might try that when we get to it. And then the year, I have this set between 18 and 30. So 2018 to 2030 is what the biggest range for that. And then the hours, the minutes, and the seconds. And then down here, just like the up button, we go between AM and PM. And if you'll notice, I have all these set to 2 for a length. And you do that over here, you can set that length. So that way the display is 2, and it more represents what we're going to send in our string. Because we're going to send the month, day, year, hour, minute, seconds, and then AM or PM to the Arduino. And that's how we'll set the real-time clock in the Arduino. And now B1 is what is going to do all the work, where we do the set. And the first thing we do is, in every command that we send to the Arduino, it has to start with the C:C, and then a 3-digit character string that tells us the command. In this case, I'm doing TIM for time. And since the N0 through N5 are numbers, the first thing we have to do is convert them to text. We do that with the covex. We're going to take N0, we're going to convert it to temp.text, which is a variable I have down here, and then we're going to append it or concatenate it to the send string. And so we're slowly going to build this send string with C:C TIM, and then 2-digit N0, 2-digit N1, 2-digit N2, and we define that in that covex command. And you use that with that second variable, so it's N0 val temp.text, comma 2, comma 0. And we'll do that for each one of these. And then at the very end, we have to do the B3, whatever text is on the B3 for AM and PM. And then we have to end it with that question mark, because that's what we use as our ending delimiter. And then we just send that out, we print string it out of the serial port. And then the Arduino will get it and manipulate it. Now the other thing I forgot to say though is when we enter the page, I do a similar thing. Only I use the substring, because on page 1 or page 0, I have this string up here. And the first 2 characters are the month, and then we'll have to skip 1, and then the next 2 are the day and the year. So I work through that using the substring command, and I go to 0, the first spot of the character, and I get 2 characters. Then I go to 3 and I get 2 characters, and I write that into these individual fields. Well, they're characters, so I still have to use that covex, and I have to convert it. So the first thing I do is I save it in the temp, has the 2 digits, and then I convert it and I store it in this value. And that way it involves a little less changing, because it'll bring those values from page 1 to page 3, and then we can manipulate them from there. So now I'm going to upload this and I'll show it to you on the display itself. Now you can see we have the time button in there and the AM is on there. And if I go to my time screen, if I tap one of like the month right now, well, the month's not a good example because 12 is the maximum, we'll tap the hour button. And you can see that it went up. And if I change that to down, you can see that it goes down. So it's all working the way we want. And when I hit that send, it should receive it or the set, it should send it to the Arduino. Of course, right now, the Arduino doesn't know what to do with it. When I go back to the time, it won't have changed the hour. You can see that it's still 10:08:45. And right now it's not counting up because I don't have it hooked to the Arduino. I have it up to the programming part. I'm going to switch that now. And you can see now it's counting back up. But it went to that 12.9 even though we had adjusted it. And now what we'll do is we'll go back to the Arduino and we'll try and get everything together. I'll even put the serial port on there because you should see the string come through from the nextion. So now if I go back to the time page and I hit set, you see that it comes through that TIM and then the value. So it's already set within the Arduino. So it'll be a fairly simple command to get it to set now. We'll do this on the input page because here's where we have the other ones where we set the high, low value and whether we want that update or not. So if the command is equal to TIM, we're going to use that same subroutine, set time, and we're going to use the value that we just collected. So now the time should be set. So now I'll upload it and we should see it change on the nextion. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.